All right, so I wanted to look at Lance Putnam's work today. So Lance Putnam is a media artist. I believe he's working at Goldsmiths now in London, and now he works, I think, almost exclusively with virtual reality and real-time virtual reality for art purposes at Goldsmiths, and flips between audio and 3D world. So as I knew Dr. Putnam, he was an audio guy, was really into making tools for music, but spent some time in a program where I was and just started moving over more and more to audio-visual things, which is the period of his work that we'll look at, and now is, I think, almost exclusively doing visual things, although has a great deal of knowledge about sound. So his work is interesting to us because it does follow on John Whitney's path. And so Lance Putnam's dissertation deals with a specific variant of using certain functions to create audiovisual works. It is a good dissertation. I recommend you read it. So for us, what's interesting is that the work we'll look at from 2007 or so, called S-Phase, and then another work from about the same time called Rapture, are both created using similar techniques that we looked at last time for JIT.mo. The difference being that he is actually using the audio features that JIT.mo implies. So when JIT.mo does a sine wave or a cosine wave, for example, those have certain implications in the structure of what we see. If we were to sonify those, we would hear some result. So Lance Putnam's work goes to some level of effort to make sure that what we hear and what we see are both interesting. And the way he does it is as follows. Let's share the screen here. So I will send you a link to watch the video in a second. So this is not the one we'll look at, but this, I believe this was a precursor to what we'll see. So S-Scale was an application that you can still download, but it only runs on PowerPC or something like that.
Amazing.
And so it itself allows you to do sort of these interesting things that show up in this piece we're going to see later. And he builds a whole compositional system in C++ to do all this stuff. So he's built his own audio library to be able to do these things. He works with a couple other people to build his own visual library to do what they need to do. Both of those things are still available to use in your own projects, but it is substantially more text-based than Jitter. So here we see some screenshots of time domain and frequency domain efforts. So these are the sort of images he gets, and these are the sort of graphs he uses to make the music and sound. So here you'll see that he's got three instances of pink noise, each running through a comb filter. So a comb filter is just a very tiny delay that creates resonant nodes in the harmonic spectrum. So it's just a delay, a feedback delay. And then you see that we hear the audio from two of these comb filters here. And then we see that one of the comb filters, there's an FFT done, and notice that this analysis is purely for the visual domain. So here we have the FFT informing X and Y, as well as the comb filters themselves informing X, Y, and Z. So this is the same sort of thing we were doing with the JIT.mo, except here we have an additional step of FFT analysis to get frequency domain information So FFT takes a time domain signal like a waveform and gives us the spectrum of the sound as frequency bends with magnitudes and phases. So here to read what he does, because I think this came up recently in, maybe Andres had this in the oral examination. Here, Lance Putnam generates pink noise. He says pink noise is generated by summing 12 octaves of white noise. The octaves of white noise are produced by generating and holding a uniform random value every 2 to the n samples, where n is equal to 0 is the highest octave. A feedback comb filter is simply a signal summed with the time-delayed output of the filter. It's a pretty simple process. He generates his own pink noise even, which it looks like he does by doing white noise at a certain decibel decrease per octave. He says the feedback in the system, which is the comb filter, causes linearly spaced resonant nodes, harmonics, in the frequency spectrum. Harmonics of some frequency are defined with some equation. Using positive feedback with a comb filter produces even harmonics, and using negative feedback generates odd harmonics. So whether or not we flip the phase or not is what positive feedback or negative feedback means. So he's able to generate either even or odd harmonics. And the pieces we're going to look at basically deal with that phenomenon, a very simple and low-level phenomenon. By controlling the delay time of the filters, you can change what the pitch is. So if your delay time is short enough, then you actually get pitches that are definable. Okay, so here he notes that the audio samples are represented visually in 2 different ways. The first of these is a time domain phase plot, which maps the left channel samples to the x-axis and the right channel samples to the y-axis, and the third unheard channel to the z-axis. So the z-axis here done much the way we did with jit.mo. We're not even hearing it, it's just used to inform a channel. But the left and the right channels will be heard and seen. So in this mode, Lissajous figures resembling clouds of particles in complex tangled strings are produced. And here's the interesting part. Curiously, by making the filter create odd harmonics, the figures display a high degree of spatial symmetry. And using positive feedback, even harmonics, curves are completely asymmetric. So he's going to play with that idea to sort of, well, to ride on John Whitney's idea of visual consonance and dissonance. Even though even and odd harmonics aren't necessarily consonant and dissonant, visually they have some sort of symmetry and asymmetry, which is an interesting discovery. The second mode of visualization here, which is, I think, used a lot less in the piece we'll watch, is a polar plot of the left channel data in the frequency domain. So he can basically plot out the FFT. And FFT is performed on the time domain data, and the magnitude and phase of the sinusoids is plotted. This mode creates a ring-like cloud of rapidly orbiting particles. By muting the noise going to the comb filter, the particles spiral inward, forming something like a galaxy. So look a little closer. This is when it mutes, you get this sort of look. So what's interesting here, in my opinion, is that he's working in an audiovisual way from the start, right? That there is the expectation from the beginning that we will hear what we see. And I think in that sense, it's a step forward from John Whitney's thing, like Bill Alves was talking about. And the result is good. And it takes a lot of work to get there, even though what we're looking at is relatively simple, right? I mean, these are simple. This is not a complex audio synthesis method. And if you knew Lance Putnam, this would not surprise you that he's working with simple building blocks, but with a thorough understanding of them, building them from the ground up. And the results speak for themselves, I think. They're pretty good. All right, so S-phase is a piece that uses this same concept. So, and this is the one we'll watch in a second. And he talks about a sort of a narrative of this piece, I guess. It's a musical metaphor of the work a cell undergoes during interphase to prepare for division. So about dividing cells. S-phase is the part of the cell cycle where DNA is replicated. So to give you a little context here, where we were working was the California Nanosystems Institute, and there was a heavy emphasis upon interdisciplinary work. And so things like how do atomic forces work, how do bio forces work was heavy in the air. So the idea of moving our work toward an art science was, I would say, paramount at that time. S phase is the part of the cell cycle where DNA is replicated. The work was inspired by observing that Lissajous figures made from harmonic waveforms can be made to split into two symmetric pieces by removing even harmonics. This splitting resembles the appearance of chromosomes after a cell's S phase, hence the title of this piece. The underlying construct of the piece is a single low-frequency harmonic waveform shaped by various filters and delays. So same idea as what we just talked about. The filters control the curvature of the form, and the delays cause the form to split into several pieces. So depending on if he's doing positive or negative feedback. Two additional delayed versions of the waveform are used to create a coherent three-dimensional Lissajous figure, so we won't hear those, we'll just see them. This mapping of time onto space reveals the phase relationships of a complex waveform, something hidden from our sense of hearing.
Dr. Thompson?
Yes.
Did you already explain how, I get that like X and Y are plotted, but like from the left and right, I still don't see, I guess, programmatically how it's creating the Lissajous, but maybe we haven't gotten there yet.
The information in the left and right channels is different. So when we run through two comb filters, the pitches of those two comb filters will be different.
But is it like tying the amplitude? Is he measuring amplitude output and then drawing a point based on that or something, or what?
Yeah, same thing we're doing with the JIT.mo stuff, right? That's the idea. So if we combine a sine and a cosine wave of same frequency,
well,
then we'll make
let me say it like this. So, because apparently I'm the only one who has a question about this. Does everyone else in the class think they could build this? Like right now, because otherwise I'm not crazy.
No. Well, I'm trying to do something different, but.
Well, but that's a good question. Do you think you could build what we see right here, right? So in Max, there's an object called pink. Mm-hmm. You can make your own comb filter, or there might be a comb filter in there. And basically, without this FFT part, could you then do what's shown here? I think the answer is yes, right? It's very simple. Pink
but
noise
the
through
FFT.
the comb.
So
the FFT analysis is only used to make these shapes, these circles, right? So that's different and actually not really used in the piece we'll watch.
Okay, and so, but I mean, the output is just amplitude sending. Can you scroll back up? I'm sorry.
Yep. So the comb filter goes directly out.
So, and it goes to the visual, meaning what though? To the Y visual. So like it takes whatever the amplitude is of that.
Yeah, I believe that this graph is slightly misleading. I could be wrong, but I believe that this comb goes directly to the X here. He could just be taking the components out of this FFT and informing X.
Okay, and it works okay because it's normalized between -1 and 1, and the graphics part is -1 to 1 also, right? Is that why it works okay?
I'm not sure how he's scaling the graphics part. It may be in ratio. So it may not, it'd definitely be -1 to +1 on the Y. But he may actually scale that too because he does have a camera that kind of moves around.
Okay. So it really, really is incredibly simple. It's very simple. This goes right into it. Okay.
Yeah. Wow. And if we look at the S phase diagram here, it's even more clear, I think. So here you see that the visual signals, okay, so we've got a saw wave going into a comb filter, and then he's using a couple low-pass filters with center frequencies and resonances. And that goes into another comb filter. And then we have the visual layer here. So X from the comb, Y and Z with little delays here. And these delays are implemented to shift the signal off of that axis, right? So I think you could probably reconstruct these. Some things are a little bit more mysterious, like he has this detoner here, and this is for the audio signal. So once it goes through here, what he does is he uses an FFT to remove non-changing frequency bends. So if the magnitude of frequency bends is non-changing, he removes them. That's the detoning part, which is interesting. And does some chorusing, multiplier, a couple delays, send it out. So there it is. That's all of it right there. And then it's just a parameter space manipulation. I hope that makes sense. I hope I understand that correctly. We could try to build it and see if we get similar results. Okay. Observing the fact that sounds in nature are produced by disturbances, a frequency domain technique of detoning is used to remove spectral components of the waveform that do not change in amplitude over time. So he's trying to remove things that are just static from the sonic part. The piece was composed using custom software. So he wrote his own. And he wrote it using the gamma signal processing library for audio, and also this GLV GUI builder. So the GUI for this looks pretty basic, but it's interesting. The basic idea behind the composition was to have a single abstract signal that could be instantiated into oral and visual representations. So I think that's probably the crux of what I want to talk about, is that there is this sort of thing that is neither sound nor vision, but could be visualized or sonified. And so when he works with it, he's working with this sort of what I would call system that grows sound and vision in a very simple way. So he would argue that that what we see here, the abstract signal, a saw wave, a comb, 2 low-pass filters, and another comb, that is not necessarily a sonic signal. That's just a signal. Okay, so the signal is based on traditional sound synthesis techniques of subtractive synthesis and phase vocoding. The instrument consists of a saw wave filtered by a feed-forward comb filter, right here. 2 parallel resonant low-pass filters, right here. And I lost my place. And a feedback comb filter, here. The first feed-forward comb filter tracks the pitch of the saw wave. So we change the delay time of the comb filter based on the input of the saw wave, which here it looks like he says is divided by 2. And allows control over the amplitude of even and odd harmonics. The low-pass filter controls the sonic brightness. So obviously if you low-pass filter something a lot, it's not as bright. And if you low-pass it less, it's more bright. And visual sharpness of the curve. So the sonic consequence and the visual consequence. The feedback comb filter allows individual harmonic sets to be accentuated, and visual form replication if the delay is long enough. Right, so if this comb back filter has a long delay, then we'll see multiple copies because the abstract signal is repeated, as opposed to not being seen as a repetition. So sort of I'm going to skip over this a little bit, but sort of interesting, like this is the score he creates. So again, he makes this score in his own, in C++. He does not delegate this to some other process. So it's just a transition from state to state. And then to actually compose the piece, he had to make this interface. So for each of these sort of states that you travel through here, there are different parametric states, and he interpolates between them in various ways going through these. So he built his own sort of score creator for such work, which I think is really interesting. And here's a zoomed in shot, and you can see there that there's a little slider there that he can implement. Really interesting. So the compositional system was designed to make this piece. However, it's general purpose enough to use to create paths through other parametric systems, which I think is a really interesting thought, even though it's simple, is that in some ways composition simply is that, right? Or music is that. It's just a journey through parametric states. How do we get from one place to another, right? Maybe we start on the tonic and we end up at the half cadence, and there's some path between those two states that's interesting. And then maybe we start at the half cadence, move back to the tonic, and get to the full cadence, and then we have our period, right? So the period is just a move through parametric states, in that case purely pitch based, but there's other states as well dealing with rhythm and timbre and so forth. All right. So that's this piece, and I'm going to send you the link. We'll do it like last time. Copy the link, and you'll be able to watch this on your own. Okay, this is the high resolution version. The other one we'll watch does not have high res, and by high res I mean it's 720p. So I'm gonna this time pause the recording, I think. Well, it doesn't matter to you. Now we can watch this piece. I hope you all have it in your link. Hopefully those of you without Wi-Fi are going to be able to do this. Here we go.
I like that one.
Top notch.
Yeah, that was cool.
Yeah, I think it's really interesting, actually. It's been a while since I watched that whole piece, actually.
Those shapes are just so. They're so like, what's the word? Organic. Like it seemed like they were, or maybe not organic. It's like somewhere in between. You know, it's like in the like the space between organic and inorganic. I mean,
Yeah, I think that the way that I was only able to get through like 5 minutes of it cleanly. That's too bad. Well, it still exists. It's on the internet, and you can watch it later. But I think that images that we might see occurring naturally are there. These sort of, it doesn't seem forced at all many times. Sometimes it does when the sound gets a little more complex. The images become noisy and a little more artificial. But what I find interesting about that, and why I really wanted to show it to you guys, was that as you move toward creating your own audiovisual thing, this is one example of how it's done. So he builds a system, right? So he could make a lot of different pieces using this same thing, right? But this is the piece that he chose. And so there is this building of the system, and then there is the ordering of the system. Like, how do I want to move through the parameter spaces exactly? How do I want to deliver this work? And I think he does a pretty good job of doing it. It's compelling in some way, and he finds these spaces to keep our interest. So what's different about this than, I think, traditionally creating art or music is that he's in some degree at the mercy of the algorithm, right? He doesn't get to change what he's using. The system is fixed. There are these many comb filters, there's this saw, there's this thing, and it never changes, right? The discipline of constraints. And as Ryan points out, the genius of simplicity is hard to obtain. Seems easy, right? But somehow it's just not. Really hard to do that. Okay. Any other thoughts about that piece?
Did anyone else like see the feedback trails, like when something went away, like you know what I'm talking about, like the whole screen would.
It was like
Yes.
a cloud. Yeah.
Yeah, so the way to achieve that is to change the alpha channel of your erase color. So if you were doing that in jitter, you would simply, for your jit.world, you would turn down the erase color, alpha. And that would not allow the screen to erase fully, right? You would always leave some remnant behind. I tend to try to avoid that technique just because I don't have control of it, right? It smears the screen, and then that's all the control I have is how much smear and not so much smear. But it is effective.
I will say the one of my favorite parts was when it started doing like paint. I don't know. It was like the texture changed, and it started like wiping like with strokes of paint.
It kind of washes over us, right? And then there's this big paint.
So I saw like hints of green they had like there, and I didn't know if that was like, whoa, are we painting, or I don't know. It was just.
Well, he is selective, right? It takes a long time before we get any color. Again, discipline, right? Not showing you color in the beginning so that when the second section arrives, that green color lets us know we've arrived at a new place.
Yeah, I thought the usage of color was just very like, it felt deliberate, and I like that.
Yeah, yeah. I'm not sure how color is actually, what that means in this piece, like where that comes from. Be interesting to ask him, I suppose.
Yeah.
He's just an email away. All right.
I have a question about this medium in particular. Before we move on, does it ever get? Something I've been thinking a lot about whenever I'm thinking about this type of art is that it's always a shape against a black background, and I find that really interesting, and I really like that aesthetic, and I personally would like to do something like that. But is there any? It seems like after a certain point that people are pretty much only interested in 3D like shapes against a blank background, and I'm wondering if there's some extension, like something that progresses past that, or something.
Yes, there is, as a matter of fact. And I think that's a really good point, actually. I was trying to find Graham Wakefield's works, T0 Coincident and Takeaway, but those don't exist any longer on the web. I'd have to get them from him personally, and I'm not sure he includes that now in his opus of works, I guess you would call it. But those are done against a white background, which is, so it's, that's different. But I see what you're saying, and I wasn't going to look at this work today, and I think I'll still save it for next week. But the works we'll look at from Dennis Miller, not the comedian, and Joao, I don't know how to say his name, Pedro Oliveira. They start using programs like Cinema Max 4D, or whatever it's called, Cinema 4D. Programs like Maya, things like that. So I've tried to stick with tools that are, or works that are similar to what you might create in a real-time interactive environment. But in a real-time interactive environment, right, I mean, what else do we have besides the black background? I mean, it's hard to say. We have some world that has an erase color. So I think by default, sometimes the tool itself can become apparent in the work, right? And I think that's a thing that's good to be conscious of. That sometimes, you know, if we are not aware of the tool, then we can have a weakness in the work. But later when we look at those particular things, we'll see that there's not so much this 3D image on a black background. And in fact, you know, when we look at a work by someone else's name who I cannot remember or say, that we'll look at soon, it actually goes away from this whole idea of 3D worlds in general. And when we look at the Allo Brain, we will see that it is not a world on a black background, right? We're inside a different world. But in the end, that world is inside a black background, right? Because there has to be some erase color in a 3D world. And I would argue that in the universe, like the erase color is also a black background, highlighted by stars and planets. I think. The erase color seems to have a high alpha. It doesn't seem to smear very often. Okay. Yes. So now looking at Lance Putnam's next work. Let me share the screen again. And unfortunately, we don't have a high-resolution version of this. But this work moves toward something different. So here you can read all the details of how this work is created. So this is basically a visualization and sonification of mathematical function. So an iterated function. And the function is actually quite simple. But the results are very interesting. As he says, the iterated map, while only producing a one-dimensional orbit, manifests a vast range of complex whirlpools, galaxies, and constellations. And so this sort of work that we're looking at, let's read about it here. The most current version of Rapture stemmed from an earlier work I did in 2007. This version was entirely grayscale and used only simple points to display each output coordinate of the equation. The manner in which the fourth dimension was represented was also quite different. Instead of rendering a triangle glyph at each point oriented according to the fourth dimension, this version simultaneously displayed multiple three-dimensional projections of the four-dimensional space. Technique is analogous to looking at the shadows cast by three-dimensional objects, or of a three-dimensional object, on three mutually perpendicular walls, as exemplified here. Access forbidden. Below are some of the images of the piece where these multiple projections can be seen. So I actually remember when he was working on this, we can see a super low-res video of that here, but we will not look at the super low-res thing. We will instead look at this. So let me give you a little context of why this work is being created at all. Why would someone write software at such a low level to do this? Like, what's the inspiration? And again, we were working California Nanosystems Institute, interdisciplinary art science sort of ideas. And in addition to that, we were in a large space called the Allosphere, where works like this could be shown. And the Allosphere was capable, and still is capable, of showing three-dimensional images, so like you would see in a movie theater with the glasses on. Three-dimensional images in a three-story sphere. So projected all around the sphere are stereo projectors that project images on a perforated aluminum black screen. So all around you, you are immersed in virtual reality, not by wearing the goggles, but actually by being in the environment. So you stand out on a bridge in the middle of the sphere, and these images are projected all around you, and behind the perforated black aluminum are rings of speakers to do spatialized sound. So that's the context of where we're coming from with this. So a great viewing place for something like this would have been the Allosphere. And so much of this work is sort of preparatory for the pieces that will be made for that specific space, and those works needed to be real time, interactive, ideally. They needed to be made in such a way where a three-dimensional space could be rendered, so that we could have stereoscopic views of those spaces. And they needed to have some sort of art science mix to meet the demands of that space. All right, so without talking about it too much, let's watch a 360p version of this video of Rapture by Lance Putnam. Actually, before we do that, I'm gonna suspend this. And if we run out of time to not watch it, that's going to be okay because you can watch it on your own time. But I did send an email last night saying that in week 5, I did say that we're going to do a project. And I know that was a long time ago, and I haven't been continuously harping on it. So, but if you have any ideas, I would like to hear them now. And I think it would be useful for other people to hear these ideas as well. So if Alex is there, I would like to hear what he's been working on.
I'm here. My computer died, so I was waiting for it to charge. Let me get on my computer in a second.
Okay. Well, does anyone else have any ideas for what their final project will be?
I have a couple ideas.
Yeah, I have a couple ideas too.
Okay, well, let's start with Andrew then.
Oh, okay. So my first idea, if I can remember both ideas in this conversation, is that, so the marching band I edit videos for has asked me to do an abstract video to mix in with the rest of their stuff. And I was like, maybe I could use elements of this project in that kind of project. And so it got me thinking, maybe I could, it's like this tribal show, I think. And so he wants it to be kind of abstract and interesting and unusual. But I thought maybe it'd be cool if I could have a mixture of this kind of stuff that we're talking about today, with maybe planes that feature videos of the different members flying over the top, while all of this is influenced by the audio being played.
Well, I mean, when you say that, I immediately think of patterns. So maybe there's something there too.
Yeah.
Specific visual patterns. He did say tribal.
Yep. And then
Native American?
I don't know. I haven't listened to the piece yet, and I don't know
or like what. So what do you mean by? Oh, so you haven't listened? Okay, never mind.
Yeah,
I just don't. Yeah, I'm wondering what tribal means.
Same. I'll have to look into it. And then the second idea was to essentially make a little video game that doesn't have physics, and see if I could do that. Because we can create objects and we can control them with parameters and we can limit their mobility and motion and stuff. So why not do something like that and have a cool little interactive piece?
Right. This is a theme that comes up occasionally in this class and often is what does it mean to make music through games? And I think that happens. I mean, there are games. I think there are some games that are purely sonic, which is interesting, and then there's other games where there's a sonic result.
Right, something like Guitar Hero or Rock Band, for example.
Oh, well, I was like, yeah, that's one example. That's a good one. I was actually thinking of a different one. I'd have to look back. I had a student write a paper about this for their project, and they mentioned some really interesting games. Where you have to work sonically in order to succeed at the game.
Like the Earthbound and Mother games, where during the fight scenes, if you tap during the music, it increases your fighting capabilities.
Oh, cool.
And the Curse of the Necro Dancer games, where you move in time to the music, and so each turn is each beat.
Oh, that's cool. Yeah, things like that. Or does the game itself generate music? What does a game like that look like? If somebody wanted to make a musical piece where the performers are game players, what do those game players do to make music? Because music in the end is a play, it's a game. But we have these certain skills that are beyond game controllers, it seems. But game controllers can branch out to be pretty complex themselves.
Is it possible for two people in their Max compilers to compile onto the same JIT world? So like I make an object and you make an object and it shows up in the same world?
You need like a server, wouldn't you? You need like your own custom server. Probably.
I could think of a way that you could do that if you did like UDP and you're both sending messages to the same world.
Yeah. I think I don't think so directly, to answer your question. If you were on the same computer, yeah, you could have you could be working on two different monitors and obviously reference the same world, and that would work. But on two different computers, I don't think it would work because of the nature of how it's working under the hood, right? It's like, so we have to get into this graphics card. So which graphics card? Like, well, that graphics card. So I'm going for this CPU to some other graphics card. I don't know how to do that. I don't think so. But I did have the same thought as Jarrett. Like, well, you could just do messaging. Like, why not? Why wouldn't it be the case that neither one of you is on the computer that renders the actual world, and that you send all your messages to that world to generate objects that would then appear in the world?
And that's also something I did for my my last piece. Whenever I was doing that visual, is or it was something I tried to do. Is I was trying to send. I did it later, but you sending UDP data to one computer from mine, so that I didn't have to use all the processing power on the one that was doing the audio, because I knew that there was a possibility it could mess the audio up if I went too hard.
Mm-hmm. I mean, I could think about to keep on Ryan's idea, that if you had a multiple, so something simple like a multiple, and it takes matrices of positions for multiple objects. So you'd have to define, I think, well, maybe it's not true, but let's say you define in the beginning that there are 64 objects, right? And you say, well, player A gets to control 32 of those objects and player B gets to control the other 32. Then simply by messaging and filling a matrix with position data and other data, then you do get to control all of those things simultaneously, right? So, but it does require some sort of infrastructure on a computer first, and then the ability to control all of that infrastructure remotely from wherever. I think would work. But on the fly sharing a render context, I don't think is possible. Could be, well, I'm not gonna say that. I don't think it's possible in a way that I know. It may be possible. I don't know the answer to that for sure, but I wouldn't be able to do it right now. Okay, Alex, you came back.
Hello.
Hello.
Hello. I was just booting everything up and making sure everything works, and I'm not gonna embarrass myself.
Well, while you're getting set up, I'm gonna read. Have you ever seen Super Monkey Ball expert level speedruns?
Yes.
Okay, no, you don't understand. They train like neurosurgeons on Super Monkey Ball. That's how crazy it is. I'm not even kidding. I don't know how we got on Super Monkey Ball, because we were talking about rhythm games, but Jarrett brought it up, and if I ever have like 30 minutes I need to kill, Super Monkey Ball, like speed runs. It's insane.
Wow. Yeah, my 14-year-old's super into speed run sort of stuff. I cannot understand it. I'm like, I don't even know what's going on.
I don't know what's going on either.
Yeah.
The control they have over the physics of the game is just insane. Okay, sorry.
Yeah. So I'm gonna allow screen sharing for Alex here. Share away, sir.
Hello. It's not a completed project, and I haven't been able to sit down and really work on everything. But the idea is that I take a simple picture like this, and we're gonna. I have to create the audio component, but basically mess around with the image using some type of input of audio. Right now we're doing MIDI messages, but I'm about to create it right here with just a mouse. Like living sculptures, just living artwork by using the pixels from a picture.
What do you mean by living?
Oh, just how it moves. I love this. I love this movement somewhere, or that like jolt back
So
and
would you
forth.
say that all moving sculptures are living?
I'm not here to debate. I'm just here to tell you I like.
I'm not here to debate either. I'm just wondering. Because I don't know if it's. I was thinking it made me think that you were going to do like a person.
Oh no, I see what you're saying. I'm sorry. No,
I think Alex is traumatized from the oral exam.
And does it die ever?
No, it doesn't die.
So can it ever really live?
Okay, I like sharing. I'm done. But this is what I did, and I worked really. So you can do a lot with this.
What is the original picture?
Oh, it's this. It's just a picture I found on Google. It say color blue, and so you can. I control the parameters down here using a JIT.shader, which is a bunch of code, and so basically you create all of this uniqueness.
So what are you doing in that shader?
Basically, I create the forces that are being applied here. I set some parameters. I set where each one of these are pixels, and I set I set the forces are basically off the distance of their original position or the distance of positions to each other, vectors, floats, stuff like that. And I'm not great at explaining this, but
I would say that what happens is that there are pixels in an image, and those pixels are eventually sent to the shader to be turned into vertices.
Okay, that's better to say.
And the vertices have movement away from the mouse or toward the mouse, for instance, or based on the brightness of the pixel, have different accelerations. So we have vertices that are points, vertices that are sent to a mesh. So we have this 2D to 3D process happening, and based on the brightness of the pixel or its or in this case, the force applied by the mouse, those vertices are shifted in space.
So so you have like the original picture that's moving, and then you have like the after part of it. Are there like two worlds going on at the same time?
Oh, it's the same world. The picture itself is being converted into pixels. I'm messing with the pixel.
Well, it's being converted into vertices.
Vertices, sorry. So so there's no two worlds happening. It's literally just the color of the vertices are represented by the pixel.
Okay.
So can you change the mesh to not display points, but to display something else?
I can do something.
Oh, cool.
Yeah, this is a relatively new feature of GL3 where you can actually do a vertex shader and get the points back into the shader. So you can keep track of points. I think Ryan did some work with this too. This transform.
Yeah, and then I got rid of it and I made them all physical objects.
Yeah.
Is this from the Amazing Max tutorial on the article?
Part of it.
Yeah, so I think it's the same one that I had done.
Yeah, and the issue here, right, with going into the graphics card and making all the effort there is that how do we then get that information back out? Because now it's living on the graphics card, and we could output the jit.gl.mesh, but the shader code doesn't have a lot of options. So for instance, we can't OSC out of the shader code. So and anything we do here has to exist in the shader code, which is not something we really have studied. but it's powerful. And, you know, I guess there's some aesthetic discussion about found tools and, you know, what does it mean to create in a medium like this? Is it necessary to create everything yourself, or does that matter? How low do we have to go? Do I have to create my own sine wave oscillators if I want to make a sine wave, or can I just use one that exists? And for me, I very much exist on the level of I'm trying to make experiences. However that happens is fine with me. I guess having control of the tools is important. I don't need to make my own hammer. In fact, I don't need to make my own guitar, but I do need to have control of either of those tools to make compelling things. So that would be my justification for using found tools, such as the one we see here. It's more important for our purposes of what results from the tool. So just like Lance Putnam, although he builds everything of his own from the ground up, but at some point he has to sequence that system, and the sequencing of the system becomes the piece, right?
Well, I think it's literally better for humanity for us to use each other's code. Like it's essentially your coworkers. We're all on the same team, and you shouldn't be redoing the same work that they've already done.
I agree with that. And at the same time, I do see the point of something that Lance Putnam did, right? Where he's not able to do the work we saw without going low. Like he's very low level with it. And it opens up a lot of possibilities. Like why code your own comb filter, right? Which he did. Why code your own sawtooth oscillator, which he did, you know? And I think there's something to that deep pursuit. But at the same time, that's not my pursuit, right? That's his pursuit. And we can all go at it differently. And I'm sure that Lance Putnam would have no problem, and in fact, he doesn't have any problem with releasing his tools such as Gamma and GLV for anybody to use. I mean, that's the point. He's just more equipped as an engineer to do those sort of things. And I think his art as a personal statement has to reflect that as well. That's who he is. Yes, looks really cool. I'll be interested to see how you make it audiovisual. I think that's a challenge, and Alex and I have discussed that. And what we've discussed are the different ways that you might do that. So one way is to simply do what the early film animators did, and to try to make musical gestures in a visual way. So maybe a time sequence of parametric data that's compelling in a musical way, but we don't hear, and then to record it and then set music to it, almost like traditional film. Another way to do it would be to try to make it so that it is audiovisual now, and that the resulting thing you record is the result of both of those media, right? Which shifts the way you listen and shifts the way you see. And then a third way would be to do more like what Lance is doing and have a abstract signal or a system that is neither audio or visual, but has results in both media. I would say those are three ways. Another way to do it is to record sounds and then try to make the visual match up with those sounds. Sort of the opposite of film scoring. All right, very cool. Thanks, Alex. I will...
yeah, sorry.
There we go. Anybody else have anything they want to talk about or share with regards to a final project?
I don't have anything to show necessarily yet because I'm still kind of theorizing it. I wanted to write something that was based on the Fibonacci sequence and then display that graphically.
Spirals.
But I don't want to just have it be the Fibonacci sequence because that'd be lame.
I don't know. It wouldn't be necessarily. I think that the way you map the Fibonacci sequence it can be almost anything, right? If we draw it quite literally, it's a spiral.
Right.
But if we look at what we just looked at, Lance Putnam says, well, you know, I've got these other things on the z-axis just to make it 3D, right?
Right.
We don't hear it, and so that mapping is or that whole process is a little bit invisible to us, or invisible sonically, whatever that is, inaudible to us. But has an effect. And I would say, like, you can do lots of things to map the Fibonacci sequence in ways that aren't just a spiral.
Okay.
And sonically, obviously, there's numerous YouTube videos about turning Fibonacci sequence into music.
Yeah, that's kind of an impasse that I'm at. I don't know if I want to write something that, like, you know, is based on the Fibonacci sequence. I really just wanted the image to be based on it, so I don't know if
Yeah,
those
I mean, I
two
guess
should
that's one
correspond.
way, and same thing applies, right? Like maybe by using the Fibonacci sequence, because I think there's two things to talk about there, right? Fibonacci sequence spatially results in spirals or different rectangles of different sizes, actually. What does Fibonacci in time mean for image? I mean, maybe it's like starts with a few vertices and ends up with lots of vertices, or who knows what that means. So there's the time and space idea of how do we map those numbers, and then there's also the idea of sound, then, which does exist in time, but also exists in space as well.
Yeah.
So yeah, for everybody, I would say that it is now April 1. I will not fool you. I'm not into that sort of thing. And but we have about a month really before the end of the universe. So it is a good time to start working in earnest now. You have all the skills you need to create interesting things. And you do that in whatever way you think is best. But it's a good time to start working toward it now. Whether it is a tool that could create things like this, although I would prefer that there be some example, or whether it's a thing like this is the challenge. Whether it involves real-time input from an instrument or whatever, so you have to let your imagination go a little bit and decide what's going to be interesting or useful, or both would be ideal. So I like the usefulness of Andrew's idea, that it's a thing that actually needs to be done. That's always a good impetus. And I like the interest of Alex's visual world. I like the Fibonacci series. Fibonacci sequence.
Thank you. English is my second language. And it's an equation, right? Like it's so. I mean, like,
Yeah.
couldn't you do? There's more equations out there. Like, could you do another equation, or could you do like, I don't know, something that we see on the board, maybe, or
Yeah.
I don't know, like, what happens if you have like the filters are basically equations. So what if like the filters themselves are being represented? I don't know.
Yeah. Do that.
Einstein on the beach. Do some more crown stuff.
I want to break glass if I hear that again.
Einstein on the beat.
Einstein on the beach. Einstein on the beach. Einstein on the beach.
The beat.
Einstein on the beat. I like that. So what you said, Alex, reminded me of a piece, and I'm going to find it. I just have to remember the name of it. I remember the guy who wrote it. And it is another piece, much like the one we were going to watch from Lance Putnam, but did not. There it is, Gestalt. That's the name of it. All right. So to conclude today, let's watch this video. This is one of my favorites. And this is around the same time period. Although I know it came out earlier than 2008, but maybe he did the HD version in 2008. Oh yeah, it's from 2003. So honorary mention at the Pre-Ars Electronica. All right, so why do I bring this up? I bring this up because this is an example of simply using a mathematical equation as the abstract signal that will be visualized in this case. I don't believe that the sonic aspect of this was done in the same way. I think it was added after the fact. But it is another way in which you could make a piece. So let's all take a time to watch Thorsten Fleisch's Gestalt, which uses a 4-dimensional equation to create a 3D rendered space, which we travel through, and we will end after that.
Very Tesseract like.
Yeah, very fractal. Like you can tell that he was going for that. It's cool. Dr. Johnson, I have a question. Can you have multiple different? Oh, something's playing. Sorry.
Had the same thing
the
happen to
hand
me.
job.
that was a bop. Can you have like different cameras and essentially make a switcher for different perspectives?
Yes.
Like in the piece. Because I couldn't tell if that's what he was doing, but like at first I thought it was just glitching, but it literally just stopped, and then like all of a sudden you're at like a new perspective.
Well, I think he did edits, right? So he took it into a video editing software and composed it, which I recommend. It's good because this rendering he did would have been non-real time, right? This is 2003. There's no way it looked that way in real time.
Okay, I got you.
Are we allowed to do editing for our project?
Absolutely, I encourage it.
So it's not the end max patch that you want, but the video.
That's right. Well, I really want both. I want to see how you came up with various parts of it, but in the end, you know, the result is the result. I, for instance, very rarely make any music without editing. Editing is a big part of it. That doesn't mean I don't, you know, have some interesting things that go into it, but in the end, the thing is the thing. If it's going to run, you know, if it's an interactive thing, then sometimes you don't get that privilege. But if it's a non-real-time fixed thing, then you do have that privilege of editing, which is a good thing to do. But like I said at the beginning of this class, I don't have time to really go into the ins and outs of a video editor. So that's up to you to do if you choose to do that. And there's free ones. I recommend DaVinci Resolve is a good one. I think you can do it in Blender too. You're on your own with that. I don't know how to do that. All right. Reaper, Jarrett says. I don't know about the power of its video editing capabilities.
It's pretty powerful.
It's pretty all right. I use it.
There's a lot of people who use it to video edit nowadays, it seems.
Can you layer videos?
Yes.
Yeah.
Yep.
All of the videos that I made last summer that were those drum set pieces, those were all just opacity, and then the thing about it is you can automate all your video effects too, like with audio.
Very nice.
Cool.
Yeah, instead of keyframes, use automation lanes instead of keyframes.
Yep.
That's really nice.
That's definitely the right direction.
Yeah, that's pretty cool.
And you can edit the code too if you really want to get like.
Do they have video plugins?
Yeah.
They have one video plugin that's their video processor, and you can make presets for it.
Yeah, and there's a bunch of already made presets that you can just cycle through.
And you can just view the source code right there.
Nice.
It's nice.
Well, there it is. Reaper for the win. All right, everybody. Well, that's all the time we have for today. I'll post the video. I will just, I think, maybe put links. I'll put links on Folio, and the video will just live as is. I mean, there's going to be long spaces of silence. But really what we did today was just discuss a couple works, and particularly Lance Putnam's ideas and how he works, I think is quite interesting. And with that, I will say goodbye.
Thank you.
Bye.
Thank you. Goodbye.